Yeah, so my name is Nakarin Hansawattana. I'll be talking about my co-op internship. And yeah, so I have applied as a backend engineer intern with Agoda, one of the fastest growing online travel agency. And Agoda is mainly known for hotel booking, but also expand their service to flights, property, and other various travel-related booking service. I have applied for a 4 months internship initially, from August to December, but I have extended roughly a month, so it becomes a total of 5. During my time there, I work in flights connectivity team, and what we do is basically provide backend connectivity between Agoda and our flight suppliers. So this includes all the search functionality where we retrieve flights itinerary from our flight supplier, all the flights booking, and all the core functionality for our flight business service. So it's completely remote. Some of my colleagues are not in Bangkok while I was working there. Some are in Europe, some are in India, some are in other provinces of Thailand. So we mainly use Slack for communications and also Outlook, and we use other standard project management tools like Jira and other code repository like GitHub and GitLab. And for routine, our team adapts a Scrum framework for software development. We have 2-week sprint, and each sprint have a unique goal set by our product manager. We have a daily stand-up too, where we update progress related to our tasks. This is also a time where we could ask all the questions, suggestions on the issues at hand within the team. So these typically last for 5 to 15 minutes. As for my responsibility as a co-op intern, I also work like other full-time backend engineers. The team is full of backend engineers and quality assurance engineer. We pick up tasks that is relevant to the ongoing sprint goal, which is about optimizing our flights connectivity API. This could be bug fixing, adding features, adding tests, and other improvement. I will expand a little bit about the connectivity API. Each task duration also varies. It could take a day for a short task, or it could take weeks if it's more complex. Due to the limited time I have here, I will just handpick a few complex tasks I have worked on to showcase. It's a bit technical, but also a bit beneficial too for the audience. I will talk about Agoda Flights a little bit to help familiarize with the overall flow and our team API. So these are some UI front end for Agoda Flights. One of the essential flow for flights booking is for searching flights itinerary. And the actual booking placement. So for search, customer typically needs to find itinerary based on certain condition, like time and place, number of passengers, whether it's a business or economic flights, whether it's a one-way or round trip. So if a customer decided that they want to book certain itineraries, they will need to provide passenger information. They need to go through all the payment process, and they need to await whether the booking placement status passed or not. So all this flow require communication with our flight suppliers under the hood. So they provide all the available itineraries that we show on our front-end application and the sites, and all the booking placements also need to go through our suppliers. This includes all the price locking mechanism too. So as some of you might know, booking price can fluctuate, and there's a mechanism to lock price and other step during the way. And so Agoda connects with many flight suppliers, and there are mainly 2 flight suppliers. One is direct airline, where flights itinerary are unique to that particular airline brand. So they just show whatever itinerary that for that brand. The other type is flight supplier aggregator. They are a little bit special. They manage supply of itineraries from multiple airlines. So it's a mix of pools of airlines that we can choose from. And since flight service been established at Agoda, we keep finding new partnership, new cooperation with new suppliers, integrating their backend with ours. these increased selections of flight itinerary to pick from. The end result of this is that it will benefit the customer, such as more cheaper price to pick from, more flight availability, more flights option to choose from. And even in COVID pandemic, we continue to integrate new suppliers. If anyone's curious, there are still a lot of booking activities during COVID time, mainly from domestic flights. And we are still seeing like millions of monthly search activity in Agoda Flights by my own estimate. So a bit more technical, a bit more detailed diagram on how back-end and front-end flow. I will not go too much into this, but all requests from front-end will be passed through an upstream back-end service, which are all internal to Agoda. And they are eventually passed to the flight supply API. This name is the API that our team manage. So it's a connectivity API. It contains all the implementation on how to communicate with all of our suppliers, how to map request response between Agoda and suppliers in a compatible format. It's acting as an adapter to external backend service outside of Agoda. And yeah, so in the next few slides, I'll be talking about the tasks I have worked on. And one of them is source code generation. And yeah, a bit about architecture of our API. Our architecture is a modular monolith. So we break up supplier related code into independent modules. So these independent modules will still be hosted on a single server and container. Purpose of this is that it provides decoupling, it reduces dependencies, and changes in a supplier logic wouldn't affect other supplier. And adding new supplier will not require too much structural change. We just need to create this module and connect it with the overall infrastructure. So how it works, typically, whatever service calling us will pass the supplier identification, and our flight supply API will look up the service and perform the required actions based on the endpoint they have requested and the supply ID and etc. So flights connectivity team maintain supplier templates. So what this means is that it's a Scala supplier module generation templates. Our code base is all written in Scala, and we have a code generation templates that generate common boilerplates and infrastructure required for flight integrations. Most of these are written with Gitter 8 in mind. Gitter 8 is a command line to generate files and directory from templates. These are come built in with SPT, which is a standard built to for Scala. If anyone took functional programming course before, you might be familiar with these things. And these are some of the things that what the supplier templates is generating. And within a service, within an independent module, there will be multiple package of code that's isolated. So we have like a connector clients, which contains HTTP implementation to external supply endpoints. There could be a REST that just based on payload. There could be a SOAP messaging protocol that use XML as a payload. We also have common package type that store all the utilities and Scala data type. And all the blue package endpoint specific logic, such as search, initial book, which is a price locking happens, and all the confirm books and other useful endpoint. And inside each endpoint packet, we have like logic to handle request response transformation, or the validation, or the early handling, and a main file that starts all these actions. Yeah. And yeah, so why do we even have a supplier template in the first place? Is that it increases the speed of supplier integrations. Before we even have supplier templates, integrating new suppliers for basic functionality takes weeks, and this can be quite the opportunity cost is quite high. But with supplier templates, it can just take days now. And this also ensure like structural integrity of new suppliers. The core structure are up to standard, and it's a good implementation. But the problem is that these generation of fixed, they're not flexible, because one of the main reasons is that there's not much powerful dynamic generation behind GitHub, the tools that we're using. So as a solution, I single-handedly developed a plugin for external generation program. It uses metaprogramming under the hood, but this means that it writes code to generate code. So I use an open source library called Scala Meta. It's very powerful. Before I approach using metaprogramming, I also experiment with other approach like batch with regular expression and string replacement. And also I use a bit of Jinja too, but we eventually settled with Scala Meta after talking with the team. And some of the features that this dynamic generation provide is that the ability to generate specified supplier endpoints. There is a dynamic HTTP endpoint generation for request, response side, or the necessary data type that comes with Scala. And one of the most powerful generation here is synchronizing HTTP call. So we are able to synchronize the order of execution and which response is needed to build the next request and how these actually interact with each other. So everything is completely generated. Thousands of lines of code can be generated at once. And yeah, so overall for something like this, we still maintain a fixed code of Scala templates. And we pass that to GTA to produce a Scala output that we could use. This is then passed into the plugin program I built. And yeah, pretty much it. And another stuff I have worked on is improve alert monitoring. So flight supply API, they are monitored by NOC engineers or NOC engineers 24/7. So NOC engineers are the people who are responsible for monitoring all the operations or the stability inside Agoda production platform. So if a certain deploy service got ongoing technical issues such as the server outage or there's a high latency in response time, then the NOC engineer will be the first to respond and they will escalate to the team that owns it. And our backend engineers are required to take part in on-call duty. The on-call person is responsible to take actions on NOC escalations. So what this means is that they need to find root cause of the problems. They need to decide what to do next, whether we should shut down certain supplier temporarily if there's some issues, whether we should notice our suppliers about ongoing issues, or we need to deploy new change to fix bugs, or we can ignore it for false alert. And all the alert measurements are logged in our Scala program in FSA, and these are stored in a data source to be analyzed by Grafana dashboard. So you can see the dashboard in the screenshot. These are the real environment NOC engineers working in. We can set alert based on certain metrics too from the data that's stored, such as whether our search success rate is below than 90%, then we alert the NOC team to handle this. And when I joined the team, there is ongoing issue with alert escalations. We sometimes have like hundreds alerts per day. And on my second day of internship, one of my colleagues talks about ongoing escalation issues. Like he keeps getting NOC escalation after midnight outside of work, 1 a.m., 3 a.m. to wake up and find like what the issue is, what should we do, and stuff like that. And a bit sad thing is that most of these alerts are non-actionable. We cannot do anything about it. It's mostly like false alert. Main reason is that flights itinerary keeps getting canceled during COVID time because there could be some infection that caused a flight to cancel or some business reason, and supplier responses with like an error code and error message. And by default, we mark all these unsuccessful responses as error under the hood. So we keep getting success rate below a certain threshold and all the alerts are coming. And also a way to deal with this is to just mark certain error as non-actionable. But our current infrastructure wouldn't allow that. Existing error encapsulation is too generic. We need more granularity in error capturing and handle it at the top service level. There's also inconsistency in code structure and for the package among suppliers. So there's increased coupling if we apply this error fix. Main reason is that newer suppliers are more polished than the older ones. Because the older ones, we don't have really a standard, what's the best standard to approach like a supplier code-based infrastructure. And yeah, as a solution, during my first few weeks there was to refactor a lot of things, a lot of code base. So I think by approximation, it's around like 5,000 lines of code I have refactored. So for one of the supplier, I have reduced like hundreds of escalation to just 10. And it's still an ongoing effort, but it's much better than initially. And yeah, so one of the last thing we'll talk about is GRPC server-side streaming. It's also another very interesting task I have worked on. So one good thing about Agoda is that there isn't much restriction on working on other teams' code base. So you can freely contribute with other team if you have like a good reason for it. I have the opportunity to work on code base outside of our team, outside of our flight supply API. And the reason is that we have like a design changes to improve the search backend for flights itinerary. It requires change across multiple teams, multiple code base. But most of the other team, they are mostly low in bandwidth. And we just decide that we will do most of the implementation first. And I have the opportunity to help one of the senior engineers for the implementations. So this implementation is about GRPC server-side streaming. For those who don't know, GRPC is a communication protocol for client-server communications. And one common protocol most web and most project people have used a REST API. People pass JSON string to it, and it's using HTTP 1.1 under the hood. It's one of the main disadvantages of this is that the payload is quite big because we are passing strings, and string could have many bytes, and it can be quite slow. And one advantage that GRPC have over REST is that it's using HTTP under the hood, HTTP2 under the hood. It uses binary payload. So this means that it's faster to serialize and deserialize message. It have a lower latency, and it's used by a lot of big tech companies like Netflix, Microsoft. Agoda is also using GRPC under the hood for a lot of backend to backend communications. This also means that this also applies to our flight supply API. It's also using GRPC for single request and response. And yeah, here's a rough architecture for the new search flow. In simplicity, all flights itinerary search requests from the front end, they are queued up and wait to be processed by FSA, the flight supply API. And we have an intermediary queue server that receives supplier response from FSA, and they have the responsibility to update cache from the response I received from FSA. And I work mostly in the implementation of the GRPC server-side streaming on the client side, on the queue server. So the blue area in the queue server, like how message is sent, how message is received, the retry mechanism when supplier failed, and also some adjustment for compatibility with our publisher subscriber architecture that we had. This was one of the last things I've worked on before I left. It's still in early testing stage, but the changes works, request response are received successfully, stream of response are cached, and yeah, but further testing is required before integrating this into a main branch, such as benchmarking against old certain point and doing some A/B testing on production. So yeah, in conclusion, I learned a lot about best practice in software development, like backend developments or CI/CD pipeline optimizations. And I get to keep up to date with like top-notch backend architectures. I gain valuable knowledge on the flights and travel business, and also various other soft skills like communication between team, outside of team, and even with our flight suppliers. yeah, I have to thank my supervisors, managers, and the whole connectivity team. They have provided me opportunity, valuable experience, and all the assistance. And yeah, that's it for my presentation.